Class 9 Science, Chapter 4, Structure of the Atom, and in this video we will discuss about discovery of electron, proton and neutron. First of all, charged particles in matter. How can we prove it? For this, we will discuss some activities which you have learnt in lower classes. First one is comb dry hair and bring near to small pieces of paper like this. First of all, comb dry hair and then that comb we will bring near to the small pieces of paper. What will happen? The comb attracts small pieces of paper. Another one is rub a glass rod with the silk cloth and bring the rod near an inflated balloon. You can see this is the rod which is rubbed with the silk cloth and this one is inflated balloon. What happens? Balloon attracts towards glass rod. Then we can conclude on rubbing two objects together they become electrically charged. It means that there is a relationship between charged particles and the structure of atom. Okay, and the concept of indivisible nature of atom given by the Dalton is not true. An atom is divisible and consists of charged particles. Now, what are the charged particles? We will discuss the discovery of these charged particles. First one is discovery of electron. Scientists, mainly Faraday, performed experiments using cathode ray discharge tubes. A cathode ray tube is made of glass containing two thin pieces of metal called electrodes sealed in it. You can see this diagram. This is a glass tube. This is one electrode. This is another electrode. And these electrodes are joined by a source of high voltage. And this is one opening in tube which is linked to the vacuum pump and which maintain the pressure of the gas in this tube. At very low pressure of the gas and at very high voltages, a stream of particles moving the tube from the negative electrode, that is from cathode, to the positive electrode, that is anode, was observed. These were called cathode rays or cathode ray particles. The flow of a stream of particles from cathode to anode was further checked by using perforated anode. Now, perforated means having small hole, small pores, okay, and coating the tube behind anode with phosphorescent material. Now, again, what is this phosphorescent material? This is zinc sulfide. Actually, this is the material which giving off light after radiation has hit it. You can see this is the perforated anode and behind it this tube is coated with zinc sulfide which is a fluorescent material. When these rays after passing through anode strike the zinc sulfide coating, a bright spot is developed on the coating. These rays themselves are not visible but their behavior can be observed with the help of certain kind of materials like fluorescent or phosphorescent which glow when hit by them. Television picture tubes are cathode ray tubes and television pictures result due to fluorescence on the television screen coated with certain fluorescent or phosphorescent materials. Now, what are the difference between these fluorescent and phosphorescent materials? Fluorescent materials cease means stop, to glow nearly immediately when the radiation source stops. Unlike phosphorescent material which continue to emit light for some time after the radiation source stops. Okay. Characteristics of cathode rays. They travel in a straight line. It can be verified if you place an opaque object in the path of these rays, then that object casts shadow. It indicates that they travel in straight line. they consist of particles. Again, it can be verified if you place a light pedal wheel in the path of these rays, that wheel start to rotate. It indicates that these rays consist of particles. Particles consisting cathode rays are negatively charged. If we apply the electric field to the path of these radiation, then these radiation deviate towards the positively charged plate. It indicates that the particles consisting these rays are negatively charged. Cathode rays can ionize gas. They can heat objects that they hit. Charge to mass ratio of the particles is independent of nature of material, of electrode, and nature of gas present in cathode ray tube. These particles were named as electron by J.J. Thomson. Now, characteristic of electron. Electrons are negatively charged, represented by E or E negative. J.J. Thomson measured the E by M. Now, what is this E by M? E stands for charge and M for mass. That is charge to mass ratio of the electrons, and this is 1.75820 into 10 raised to the power 11 coulomb per kilogram. Another scientist, R.A. Millikan, using oil drop experiment, determined the charge on the electrons, and this charge is 1.602176 into 10 to the power minus 19 coulomb, and this is negative. That's why this minus sign is used here. We can find out the mass of electron by using this. That is, if we divide charge by charge to mass ratio, then we can get the mass of electron. Put the value. This is the value of charge. This is the value of E by M. If we solve it, we will get the mass of electron, which is 9.1094 into 10 to the power minus 31 kilogram. Discovery of protons. In 1886, Goldstein discovered existence of positively charged rays in the discharge tube by using perforated cathode. Again, perforated means containing small holes. These rays were named as anode rays or canal rays. Now again, why they were named as anode rays? Because these were seemed to be coming from anode. That's why anode rays. And why canal rays? Actually, this is the perforated cathode, and the perforation or hole of this cathode is like a canal. That's why these rays passing through these holes. That's why these rays were named as canal rays. The discovery of proton can be attributed to Rutherford. Characteristics of canal rays. Travel in straight line. Consist of particles. Particles consisting of canal rays are positively charged. If we apply the electric field, these rays deviate toward the negative plate. It indicates that these particles consisting canal rays are positively charged. Canal rays can ionize gas. They can heat objects that they hit. But charge to mass ratio of the particles is depend on the nature of gas present in cathode ray tube. Okay. The smallest and the lightest positive particle was obtained from hydrogen. It means if hydrogen gas is taken in the tube, then whatever the positive charge particle obtained for that particle, this E by M ratio is maximum. Okay, and in two situations it may be maximum. Either charge is highest or mass is lowest or smallest, and it was proved that the mass is smallest. That's why the smallest and the lightest positive particle was obtained from hydrogen, and it was called proton. Okay. Characteristics of proton. Protons are positively charged, represented by P or P plus. The E by M, that is charge to mass ratio of the proton, is 9.6 into 10 to the power 7 coulomb per kilogram. The charge on proton is plus 1.602176 into 10 to the power minus 19 coulomb. Actually, the magnitude of this charge is equal to the charge on electron. Only difference is this is positive. And we can also find out the mass of proton by using this E divided by E by M. Put the value. This is the E and this is E by M. If you solve it, this is 1.6726 into 10 to the power minus 27 kilogram. And it is 1837 times heavier than an electron. Discovery of neutrons. Neutrons were discovered by Chadwick in 1932 by bombarding a thin sheet of beryllium by alpha particles. Actually, these alpha particles are helium nucleus. Helium can be represented like this, and it has 2 electrons. If these 2 electrons are removed, then this will acquire the 2 positive charge. This is called alpha particle. Okay. And this neutron has no electrical charge. That's why it is neutral. It is represented as N. Its mass is 1.6749 into 10 to the power minus 27 kilogram, and it's slightly greater than that of proton. It is 1842 times heavier than an electron. Now we can compare the properties of these fundamental particles: electron, proton, and neutron. Electron, proton, and neutron. The symbol is for electron E, for proton P, neutron N. Charge, absolute charge in Coulomb. Charge on electron is same as the charge on proton. Only difference is sign. Charge on electron is negative, charge on electron is positive, and its magnitude is 1.602176 into 10 to the power minus 19 in both the cases. And for neutron, charge is 0 because this is neutral. Relative charge, electron is -1, proton is +1, neutron is 0. Mass, this is the absolute mass for electron, 9.109382 into 10 to the power minus 31 kilogram. For proton, 1.6726216 into 10 to the power minus 27 kilogram. For neutron, this is 1.674927 into 10 to the power minus 27 kilogram. If we express these mass in U, then for electron, this is 0.00054 U. For proton, this is 1.00727. For neutron, this is 1.00867. And if we find out the relative masses of these related to each other, then mass of electron is considered as 0, mass of proton is 1, and mass of neutron is 1. Okay, student? Thank you. Subscribe my channel. In the next video, we will discuss about atomic models.